Okay, welcome to day 2 of our countdown to the AP exam. And today we're going to look at a polar question and an area question. Both were on the 2014 AP exam. So for polar, what you want to remember, of course, is the area of a polar curve. Please, 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 if nothing else, just know that simple formula that the area is from alpha to beta, 1/2 r squared. But then you often need to know how to convert from polar to rectangular. So you also need to know that the x-coordinate is r cosine theta and the y-coordinate is r sine theta. You also may need to know that r is equal to x squared plus y squared. And tangent theta is equal to y over x. The slope of a polar curve can be given by dy d theta over dx d theta. Now, I don't memorize this formula because I just use this. I find r sine theta and take the derivative of that divided by x. I find x and take the derivative of that. But if you want to memorize that formula, then go right ahead. Okay, so this first question asks they give you the two curves and let R be the shaded region inside of both curves. Well, one thing you want to recognize is that this curve to the left is simply a quarter circle. So this is just a quarter circle. So to find the area of this part of that graph, we can just use the formula for a quarter circle, which is pi r squared over 4. So this would be pi times 3 squared over 4. And then to find the area of this curve, it's simply 1/2, because this is the formula, the integral from 0 to pi over 2. And it gave us bounds. It told us that the curve went from 0 to pi. And looking at this, we can tell that this graph goes from 0, it sweeps from 0 to pi over 2 to find this area of the curve. 1/2, and then r is 3 minus 2 sine 2 theta, parentheses, parentheses squared. Now, one of the suggestions that I would make for you, because this was a calculator active question, one of the suggestions that I would make is that you would put your calculator in polar mode and make sure it's in radian mode, especially you who take physics. So put your calculator in polar mode and radian mode, and then put in your calculator r is equal to, so you put that function in your calculator, 2 theta. And then on this part of the test, when you put it in your calculator, you can just do the integral from 0 to pi over 2 of r squared d theta. And if you don't know how to paste that into that integral, please see your teacher. But that is how I would do that on the calculator. At any rate, the final answer for that was 9.707 or 9.708. Either one was accepted. And the points came from this is 1 point for the integrand. So you got 1 point for this integral with 1 point for the limit. So let me write over here. 1 point for the integrand. 1 point for the limit, and 1 point for an answer. Now, if you didn't recognize that that circle was a quarter circle, it's all good too, because the other alternative answer for that would have been, so you could have done this, or 1/2 the integral from 0 to pi over 2 of r1 squared, which is that first one, plus, now the circle goes from pi over 2 to pi. So you could go from pi to pi over 2, 3 squared, which is the radius of that circle. So either of those answers would have gotten you all of the points. B, find the value of dx d theta. So in order to find dx d theta, we have to find x. So remember, x is equal to r cosine theta. So in this case, r was 3 minus 2 sine 2 theta, close parenthesis, and then cosine theta. And you can do this one of two ways. I would probably distribute and get 3 cosine theta minus 2 sine 2 theta cosine theta. And then I would use my calculator to take the derivative of this. So I go back to function mode and put all of these in as x and find the derivative at pi over 6. So where you got your point for this was simply writing this. So you got 1 point for this. So actually I probably wouldn't have simplified it. And I would have just put this in my calculator in function mode and found the derivative at pi over 6, which is negative 2.366. And that was worth 1 point. Okay? If it's calculator active, remember to use your calculator smartly. So it's calculator active. You don't have to do all this by hand. You don't have to do the product rule, chain rule. You would simply just put this in the calculator and find the derivative at pi over 6. C asks us to find the distance between the two curves from 0 to pi over 2. So the distance between the two curves is simply subtracting the two curves. Since r equals 3 is the outside curve, the distance is equal to 3 minus 2 sine 2 theta. Okay? And there was 1 point for recognizing that. So then they want to know how fast, find the rate at which the distance is changing when theta is pi over 3. So then we have to find the derivative of this with respect to t. So 3 minus 3, that zeroes out, and that'll give me plus. So I get the distance, when I simplify it, is 2 sine 2 theta. And I'm taking the derivative with respect to t, so that's going to give me 4 cosine 2 theta. But I'm not done because I'm taking the derivative with respect to t, so I have to do d theta dt. And from here, all the information was given, so this will be 4 cosine of 2 times pi over 3. And are we told the distance on the rate at which, are we told d theta dt? I think we're told that somewhere. Find the distance when the curve is changing from somewhere to somewhere. Do I not know d theta dt? Where did I get that from? Oh, I'm not taking it with respect to t. It says find the distance, the distance between the two curves is changed, find the rate at which this changes with respect to theta. It helps to read. So this is d theta, so I don't need d theta dt. Blah, blah, blah. I don't need that because I'm taking it with respect to theta. And so that answer then is simply, and once again, I didn't have to do that by hand. I could have used the calculator to do that, to get negative 2. Okay? And finally, I was thinking of d in my head when I did that problem because I knew we needed d theta dt somewhere. So for this one, they want us to find the value of dr dt. So that means we're taking the derivative of r with respect to t, and they gave us d theta dt. So r is this, so dr dt is equal to negative 4 cosine 2 theta. I use chain rule to get the negative 4, and then the derivative of sine is cosine. And because I'm looking for dr dt, I have to do d theta dt. Sorry about that. So that just gives me, and so you got 1 point for this, for using chain rule. And then the answer is going to be negative 2 times 3. The answer is negative 6, and you got 1 point for that. Okay? So that is a polar question. You're guaranteed to either have a polar or a parametric on the test. Chances are it's going to be parametric, but I would be prepared for polar just in case. Now the average score on this was 3.96, which is a little low. So you want to try to do better than that. And things that you need to make sure is that you're notating your information correctly. Be able to use your calculator effectively, and be able to find the integral that involves the complicated integrand, but again, you can do that with your calculator. All right, so this next problem was also on the 2014 administration, and for this problem, you're going to have to recall the area between two curves and the arc length formula. So remember, the area between the two curves is upper function minus lower function, and if I do upper minus lower, my bounds are x values. If I do right minus left, then my bounds are y values. Okay? And this is arc length of a curve. This is not parametric. This is just a curve, and you're going to need that as well. You also have to remember the volume of how to find volume. So using the disk method. We use the disk method when the area in question is flush or adjacent to the axis of rotation. We use the washer method when there's a space between the two. One of the common mistakes I see for the washer method is forgetting that the outer radius is squared in and of itself, and then the inner radius is squared. It's not outer minus inner quantity squared. They're each squared individually if you're using the washer method. Whereas with disk method, it's the f of x minus the axis of rotation quantity squared. Okay, so to find the area, we have this exponential function and this linear function. So the area is going to be upper curve minus lower curve, and we're told that the bounds are 1 because these are x values, so I know this is 1. So I'm going to integrate from 0 to 1, my curve on top minus my curve on the bottom, dx. Now for this curve, I'm going to have to use a u substitution. So I'm going to come over here and do a u substitution. I'm going to let u equal to x squared, du equals to 2 dx. So 1/2 du is equal to x. And since I have x here, I'm going to replace this and I'm going to integrate. Notice when I do this, I am not putting limits because these are u values now. So my new value is e to the u du 1/2, which is 1/2 e to the u. But I'm going to change that to x values. I'm going to go back to x value and do 1/2 e to the x squared, okay, because I'm going to go back to those limits. So integrating this, I get 1/2 e x squared plus x squared over 2. So x squared over 2 times 2, so it's just x squared. And I'm evaluating this from 0 to 1. So doing that gives me 1/2 e plus 1 minus, now remember, e to the 0 is not 0, it's 1. A lot of times students make that mistake, so this would actually be minus 1. And why do I have a mistake here? Actually, it's minus 1/2, I'm sorry, because it's e to the 0 is 1, but I have to multiply times 1/2. So it's minus 1/2. So my final answer is 1/2 e minus 1/2. Okay? So you get 1 point for the answer. Because this was calculator inactive, you get 1 point for the antiderivative. Derivative, however you spell that. And you got 1 point for the integral. Okay? So it's worth 3 points. Be careful on making, don't make just simple mistakes like I was there. Right, but do not integrate an integral expression that gives us the volume of the solid when it is rotated about the horizontal line y equals -2. Okay, because this is my axis of rotation and it is not flush with my area, I'm going to have to use the washer method. So it's going to be top curve minus the axis of rotation squared minus the bottom curve minus the axis of rotation squared, because it's outer radius minus inner radius. So my inner radius, I don't know why I drew that there, that's my inner radius. Okay? So it's the integral from 0 to 1 of the outer radius, which is x e to the x squared minus negative 2 squared. That's my outer radius, minus my inner radius, which is negative 2x minus negative 2 squared dx. And that was worth, oh, what did I forget? I forgot my dessert. Don't forget your dessert. I forgot pie. So this was worth 2 points. Okay? That was worth, the integrand itself was worth 2 points. And then you got 1 point for limits and constant. And when they say constant, they mean pi. Okay, so worth 3 points. Now this last question is one of my favorite questions because it's just it just made you think. And I remember when my kids took this question, they came back and told me that I had not taught them perimeter. Well, they were right. I didn't teach them perimeter because, well, you learn perimeter in 3rd grade or something. Perimeter is just the sum of all the sides. So that's a piece of information that you know. What they wanted to see if you could do is find the length of each of these curves. That's what they were testing. So let's start with this linear function because I think this is pretty cool. If we were to do the math for this, we'd find that this is 1 and this point is negative 2. Okay? And we know that because if I put in x is 1, I get negative 2 here. So my y is negative 2. So this is negative 2. So I could use Pythagorean to find this length. So this would be 1 squared plus negative 2 squared, which is 5 squared. So the length of that is radical 5. Using Pythagorean. But this is what I think is cool. If I use the arc length formula, which is L is equal to the square root of 1 plus f prime of x squared, if I were to use that formula, I also get radical 5. So I think that's pretty neat. So this would be the square root of 1 plus the derivative of negative 2x is negative 2 squared, and look at that. That is radical 5. That is, to me, the coolest thing ever. Then the length of this curve, so that's the length of that curve. The length of this curve, you had to recognize if you input e into this function, if you put 1 into this function, you simply get e. So this curve from here to here, the length of that curve is e, and then I have to go a little bit further because we're talking about a length, so it's not negative. So the length of this is 2, so the length of that entire curve is e plus 2. Okay? Now, how do I find the length of this curve? Once again, we're going to use our curve length formula. So L is equal to the square root of 1 plus, I have to find this derivative. And you got 1 point for finding the derivative of y. So dy dx is equal to, I'm going to have to use product rule. So I keep x the same. The derivative of e to the x squared is 2x e to the x squared plus I take the derivative of x, which is 1, and then e to the x squared. So that's the derivative. You got 1 point for finding that derivative. And then evaluating that derivative at 1, no we don't. We just leave that there. So the length is, I'm going to need more space to write that length. The length of this is going to be the square root of 1 plus Let's clean this up a little bit, though. I can write this as 2x squared. So 1 plus 2x squared e to the x squared plus e to the x squared quantity squared. Is that not fun, or what? So this plus this and you could take out that ex squared if you like. I don't like, so I don't. Square. And that is the length of that curve. And what did I do wrong? I have to integrate from 0 to 1. And I also had to integrate this from 0 to 1, but it still ended up with radical 5. We have to integrate this from 0 to 1 dx. And that is our answer. I forgot the integral is from a to b of the curve. It's an integral. So make sure you write that integral because that's important. I got so excited with the math of that I forgot the integral. But that's how you solve that. Okay, a lot. That's a lot we covered there. So the average for this problem was 4.45. And when you think about it, it was strictly an A-B problem until you got to the end. That's where they threw in the BC. And again, they want us to stress communication skills with you. Labeling your work. Make sure your work is organized and your presentation of your work is organized. That's important. Understanding that f of x, when f of x is greater than g of x, then it should be f of x minus g of x. And I think that's where a lot of kids get in trouble with the volume, because it matters to me, and I mark off on my kids' paper if they were to do 2 minus this, because it's always top minus bottom. Top minus bottom. Even though you get the same answer, I prefer that you write it top minus bottom. Okie dokie? All righty, you are so going to make a 5 on this AP exam. You're going to do so well. Just keep practicing, and it's going to be good. Thank you. Have a great day.